Welcome back to the session on evaluation of double integrals using numerical methods. In the previous session, we discussed the evaluation of double integrals using the trapezoidal rule of integration. Now, here we shall discuss the evaluation of double integrals using Simpson's rule of integration. Let us consider the double integral I is equal to double integral f of xy dx dy, where the region of integration is the area bounded by the ordinates at x is equal to a, x is equal to b, y is equal to c, and y is equal to d, this line. Now, in order to apply the Simpson's rule of integration, we divide this whole region of integration into small rectangles whose dimensions are h and k, that is each of width h and this height is k. Here we know that by Simpson's rule of integration, integral from x0 to x2 f of x dx is equal to h by 3 into f of x0 plus 4 times f of x1 plus f of x2, where x0, x1 and x2 are equidistant points, and f of x0, f of x1 and f of x2 are the corresponding function values of y is equal to f of x. H is the width of intervals. All the intervals are same width. Therefore, we can write this integral from x0 to x2 f of x dx is equal to h by 3 into f of x0 plus 4 times f of x1 plus f of x2 by the Simpson's 1/3 rule. In order to apply this rule, we want 3 points or 3 pairs x0 y0. Y0 means f of x0, x1 y1, y1 means f of x1, and x2 y2, y2 means f of x2. This result is derived in the session of numerical integration using Simpson's 1/3 rule. Now, in order to evaluate this double integral, we have to consider this rectangle A, C, E and G, because Simpson's rule cannot be applied to one sub-rectangle like AB, IH. We have to consider all these 4 rectangles, that is the rectangle A, C, E, G, because we want 3 points to evaluate or to apply the Simpson's rule of integration. Therefore, our area of integration is A, C, E, G, consisting of 4 adjacent sub-rectangles. Therefore, we can write integral from yj to yj plus 2. This is yj, here yj plus 1. This is the point xi yj plus 2. And integral from xi to xi plus 2. F of x comma y dx dy, which is equal to integral from yj to yj plus 2 Here for this inner integral, we apply this rule of Simpson's 1/3. We can write value of this integral as h by 3 into f of xi y, h by 3 into f of xi comma y plus 4 times f of xi plus 1 comma y. This is the point, xi plus 1 y. That is the midpoint, plus f of xi plus 2 comma y. This is the corresponding end point of dy. This is equal to, we can write this as h by 3 into, because h by 3 is a constant which can be taken outside of this integral, h by 3 into integral from yj to yj plus 2 f of xi y dy plus integral from yj to yj plus 2 f of xi plus 1 comma y. f4 is a constant which can be taken outside of this integral. 4 into integral from yj to yj plus 2 f of xi plus 1 y dy plus integral from yj to yj plus 2 f of xi plus 2 comma y dy. h by 3 is common. This is equal to, here as in the previous session, we use the notation f of ij. For f of xi comma yj. Now, this is equal to h by 3 into, we shall use the Simpson's 1/3 rule for each of these integrals. We get h by 3 into, for this integral we can write k by 3 into f I comma j means f of xi yj plus 4 times f of xi yj plus 1, that is I comma j plus 1, plus f of xi comma yj plus 2, that is f I j plus 2. Plus 4 into value of this integral by using Simpson's 1/3 rule can be written as f of xi plus 1 comma yj. By our notation, we write f I plus 1 comma j in the suffix, plus 4 into f of xi plus 1 comma yj plus 1, that is f of xi plus 1 comma yj plus 1. By our notation, we can write f I plus 1 comma j plus 1 plus f of xi plus 1 comma yj plus 2, that is f I plus 1 comma j plus 2. Plus, for this integral, we can write value of this integral as f of x I plus 2 comma y j, that is f I plus 2 comma j plus 4 times f of x I plus 2 comma y j plus 1. By our notation, we can write f I plus 2 comma j plus 1 in the suffix plus f of x I plus 2 comma y j plus 2, that is f I plus 2 comma j plus 2. This is the value of this third integral. Here k by 3 is common for these three terms. Which is equal to h into k divided by 9 into f I j plus f I plus 2 comma j, this term f I plus 2 comma j plus f I j plus 2, this term, this one f I j, f I plus 2 comma j, f I j plus 2 plus f I plus 2 j plus 2, f I plus 2 j plus 2. Plus this h k by 9 is common, plus 4 times f I plus 1 j, this one 4 into f I plus 1 j plus f I j plus 1, this is the term f I j plus 1 plus f I plus 2 j plus 1, this is the term f I plus 2 comma j plus 1 plus f I plus 1 comma j plus 2, 4 into f I plus 1 comma j plus 2 plus the remaining terms are here 4 into 4 f I plus 1 j plus 1 means 16 f I plus 1 j plus 1. Which is equal to, this can be written as h into k divided by 9 into sum of the values of the integrand f of x y at the corner points a c e g. These are the corner points a c e g. f I j means f of x I comma y j. x I y j is the is a corner point. f I plus 2 comma j means f of x I plus 2 comma y j, that is the value of the function f of x y at the point x I plus 2 comma y j, which is the point x I plus 2 comma y j. This is the point. F I comma j plus 2 means the value of the function at the point x I comma j plus 2. x I comma j plus 2, this is the point x I y j plus 2. F I plus 2 comma j plus 2 means value of the function f of x y at the point x I plus 2 comma y j plus 2. x I plus 2 y j plus 2 means this is the point. That means this is the sum of the values of the function f of x y at the corner points a, c, g and e. We can write sum of values of f of x y at the corner points A, C, E and G, plus this term is 16 into f I plus 1 comma j plus 1 means value of the function f of x y at the point x I plus 1 comma y j plus 1, which is the point x I plus 1 y j plus 1 is the point at the center, that is the value of the function f of x y at the center point I. 16 into value of the integrand f of x y at the center point I, plus 4 into sum of the values of function f of x y at the remaining points b, h, d and f. The remaining points are b, h, d and f, that is 4 into sum of the values of f of x y at the remaining points. Remaining points means the points b, d, h and f. H into k divided by 9 is common, where h is the width of each interval and k is the height of each interval. This is the rule of Simpson's one-third rule of integration for evaluating a double integral. This can be written as double integral f of x y dx dy as hk divided by 9 into the values of the function at the corner points means f at A plus f at C plus f at E plus f at G, plus 16 into value of the function at the center point I, that is 16 into f at the point I, plus 4 into sum of the values of the function at the remaining points means 4 into f at B plus f at D plus f at H and f at F. 4 into these values. Now consider one example to evaluate a double integral using the Simpson's rule of integration. Evaluate double integral from 0 to pi by 2 and integral from pi by 2 to pi cos x plus y dx dy, where h and k be taken as pi by 4. Both h and k are same, both are equal to pi by 4. In order to evaluate this double integral by using Simpson's rule of integration, we split this total region of integration into smaller rectangles like this. Here the axis varies from pi by 2 to pi. Variation of y is from 0 to pi by 2. H and k are taken as pi by 4, means we have to split this range into pi by 2 comma 3 pi by 4 and 4 pi by 4, that means pi, and the values of y are 0 pi by 4, and pi by 2. 2 pi by 4, that means pi by 2. Now, we draw the rectangles like this. Here the point is A, which is the point pi by 2 comma 0. B is the point 3 pi by 4 comma 0, and C is the point pi 0, pi comma 0. The point H is here. This is the point H. X coordinate is pi by 2, y coordinate is pi by 4. This is the center point I. This is the point 3 pi by 4 comma pi by 4. This point is D, which is pi comma pi by 4. G be the point, here x coordinate is pi by 2 and y coordinate is 0 pi by 4, then pi by 2. F is the point, here x coordinates are 3 pi by 4 and pi by 2. This is the point E, which is pi comma pi by 2. These are the corresponding points. Now, in order to apply the Simpson's rule, we want to evaluate the function f of x y at all these points. Here f a means value of the function at a is the point pi by 2 comma 0, that is cos x is pi by 2 plus y is 0, that is cos pi by 2, which is equal to 0. Similarly, f b is equal to cos 3 pi by 4 plus y is 0, therefore, cos 3 pi by 4, that is minus 1 divided by root 2. F c, that is for c the points are pi comma 0, therefore, cos pi plus 0, cos pi, that is minus 1. Similarly, f h, value of the function at h, which is minus 1 by root 2. F I, value of the function at I, which is minus 1. F d, that is the value of the function at this point pi comma pi by 4, which is minus 1 by root 2. F g is equal to minus 1. F value of the function at the point f, that is minus 1 by root 2, and value of the function at e is the point pi comma pi by 2, that is value of the function e means cos pi plus pi by 2, that is 0. Value of the function at the point e is 0. By this rule of Simpson's on third rule of integration, we can write the required value of the double integral as hk by 9 into f a plus f c plus f e plus f g plus 16 into f I plus 4 times the remaining values of the function at the remaining points, which is equal to, here we can write the required integral as integral from 0 to pi by 2, integral from pi by 2 to 0, cos x plus I y dx dy as sum of the values of f at the corner points, that are which are here hk by 9 means both h and k are pi by 4, that is pi square by 16 into 4 into 0 minus 1 minus 1 minus 0, which are the sum of values of f at the corner points, plus 16 into value of the function at the point at the center point I, which is minus 1, 16 into minus 1, plus 4 into value of the function f of x y at the remaining points, means here the remaining points value of the function at the remaining points are minus 1 by root 2, minus 1 by root 2, all are minus 1 by root 2. That is equal to, on simplification we will get minus pi square divided by 144 into 18 plus 8 to root 2. That is equal to minus 2.0091. This is the required value of the double integral, the given double integral. Now, let me conclude this session. In this session, we discussed the trapezoidal rule of integration to evaluate a double integral, and we have done an example also. Hope that you have understood the session. Thank you for watching this class. Have a nice day.